done nucleophilic addition reactions and addition elimination reaction. Okay. So after that, we had I have told you that carbonyl group shows nucleophilic addition reactions, addition elimination reactions, then reductions, then oxidation. Okay. Then properties due to the alpha hydrogen of aliphatic aldehydes and ketones, and the electrophilic substitution reaction. Okay. So I'm going to do the reduction reaction. So reduction of aldehyde and ketones. This is the advantage of aldehydes and ketones. It is similar only. Okay. Let us first try to understand. Then we will do the example. See, reduction means addition of hydrogen or removal of oxygen. All right. So this carbonyl group is having double bond, so it is unsaturated. So obviously hydrogen can be added. So this is not a chemical reaction; it's only a scheme. So if I add here 2 hydrogen, there is 1 hydrogen will come here and 1 hydrogen will come here. Will add across double bond. So what I'm going to get now? See here. I'll get here hydrogen and I'll get here oxygen. So what will happen? A carbonyl group on initial addition of hydrogen, it will give us corresponding alcohols. And you have seen that when you remove this hydrogen from alcohols, you get back the aldehydes and ketones. Primary alcohol gives us aldehydes and secondary alcohol gives us ketones. Now, if I further add 2 more hydrogen, so where I will add now hydrogen? Yes, I will add it here. If I add this hydrogen here, and if I add this hydrogen here, what will happen? This bond is going to break because valency of carbon you cannot exceed 4. 1, 2, 3. If I add 1 more, this has to go. So if this goes out, what we get now here? You get this. That is, you get here everything. Okay. So here I can tell from here to here this step is called partial hydrogenation. And from here to here I can say is a complete hydrogenation. Okay. So now by choosing the reagent, we can stop this reaction here, or we can go up to here. So we are going to discuss the hydrogenation in 2 ways. We will go for partial reduction and we will go for complete reduction. Understood now? Okay. See now here, we'll write partial. See, if you read logically now, you don't forget. Partial reduction. In your book, they have not mentioned partial reduction, but let us try to remember like this. Okay. So you can write now here that aldehydes and ketones on reduction with catalytic hydrogenation means what we are going to use? We are going to use hydrogen in presence of nickel. Catalyst like nickel, we can use nickel, palladium, platinum, all these things we can use. Then sodium Borohydride. What's the formula of sodium borohydride? NaBH4 or lithium-aluminum hydride or lithium-aluminum hydride LiAlH4 here corresponding alcohol. Please write after this, then I'll do the reaction. Please write. No, no, ठीक है मैं थोड़ा इधर मैंने पावर लगी So I can write now. So I have taken here acetaldehyde. So I can use all this reagent, okay? Instead of writing it separately, I'll try to write it like this. Huh? I'll write here now 2 hydrogen and here I'll write the condition H2 nickel. Then I'll use NaBH4 or lithium-aluminum hydride. Okay? This is one followed by addition of water. Actually, one more thing I did not write, huh? I'm very sorry. This, nah. After that, I'll write here sodium in ethanol. No, I will write here one more. Sodium amalgam. Amalgam in ethanol. Okay, so this is all right. NaHG C2H5O. Please don't mind, huh? NaHG C2H5OH. So what we are going to get? In all these cases, we are going to get CH3, CH8, OH. That is, you are going to get ethanol will give you ethanol. Okay. Now this reduction is called Borohydride. This is called Borohydride blank reduction. This last one I have done only for your entrance. Borohydride blank reduction. Please write. So now this is aldehyde and this is primary alcohol. So please remember, aldehyde will always give you primary alcohol. Okay. Now similarly, if I do the reduction of a ketone, now I will not do it. You will write it by yourself. See, this is acetone or propanol. Propanol, what is this? This is a ketone. So one hydrogen will be added here, one will be added here. So what you are going to get? You will get here isopropanol or propan. You will get here now isopropanol or propan 2-ol. This is what? This is a secondary alcohol. So reagent is same. Please write it here. Same way you write. So it will be a practice for you. Please write. And after finishing, please tell me. Time is very less. If I take classes like this now, so it is going to take infinite period to finish. I want to convert it into normal class, not like this typical online classes that I'll give lecture, then you will hear, sit down and hear it. Lelep?
Yes, sir.
Okay. Now I'll tell you one thing, huh? I'll give you a question. This question is important, huh? See here. This again for instance. What product, go on writing, what product is obtained by the reduction of butyl by 1 hydrogen over nickel, 2 sodium borohydride, 3 lithium-aluminum hydride. All right. Now, what is butyl? See here, one double bond is there. So it is C3. Okay. In exam, how we are going to write? We'll write here. But means 4 carbon. We'll write like this. We know aldehyde is always, Al is aldehyde, aldehyde is always last or first carbon. So I'll write here now this. And this is first carbon. Then this is second. Then this is third. And this is fourth. So now you have En, is double bond. That is from second carbon double bond start. This. Okay? So valence carbon should be what? 4. So we'll make it now. See, it is 1, 2, 3, 4. 1, 2, 3, 4. I'll put one hydrogen. Then 1, 2, 3. So I'll put, what I'll do? I'll put one hydrogen. And this is this. So this is the way to write correct structure. Now what does it say? That what product is obtained by the reduction of butanol by the hydrogen over nickel. Please remember, hydrogen reduces both aldehyde and double bond. Both aldehyde and double bond. So in that case, what I'll write now here, H2, and here I'll write nickel. So I'm going to, we know alcohol will be converted to what? Alcohol will be converted into, aldehyde will be converted into alcohol, primary alcohol. And hydrogen also will add across the double bond. So what we are going to get here, CH2, 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 OH. Butanol. Alright, this is butan 1 all. Now we'll go for sodium borohydride. Okay. Generally, we are always being told that sodium borohydride only reduces aldehyde to alcohol. It does not reduce double bond. No. Sometimes sodium borohydride also reduces double bond, but it is not as efficient as hydrogen. So a part of the molecule will be converted into this, and part will be remaining in the unsaturated condition. So here I'm going to write sodium borohydride and water, which will give first unsaturated aldehyde plus, sorry dear, this. So what is the name of this one? This is but2in 1 or plus it will give you the same thing. Okay? In your textbook, they somehow did not mention this. Forget. For entrance, you have to be very, very specific. And when I take lithium-aluminum hydride, lithium-aluminum hydride is a very strong reducing agent, yes, but it does not reduce double bond. It is stronger than that of the sodium borohydride, but I do not know why it cannot reduce double bond. Every reagent has a specialty. Sorry. Lithium, aluminum, hydride, and water. So it will only give you this. So you get here now CH2 double bond CH CH2 butan 1 all. And this is, this is but2en 1 all. Okay. Now write down. This is for your entrance. For board also it may come. If it comes in the board, this one, please write this. Don't write the other one. Because I do not know whether the teacher knows or not. Unless later on you say that sir has given us wrong information. But I'm not wrong. Done? So, finish?
Yes, sir.
Okay. Then we will go for complete reduction. Complete. Right. Right. Complete reduction. Hmm. That complete reduction of LDH and ketones give corresponding alkanes or corresponding hydrocarbons. Complete reduction of aldehydes and ketones give corresponding hydrocarbons. Right. It can be achieved by one. Right. Clemensan. Clemensan reduction. And second is Wolf. The spelling is double F. Wolf Krishna. Wolf Krishna reduction. Okay. Now we will go for one. Clemensan reduction. What is Clemensan reduction? When aldehyde and ketones are heated with zinc, mercury, amalgam with concentrated HCl get reduced to corresponding hydrocarbon. Okay? So how it will happen? We know the zinc mercury amalgam, mercury does not reverse, mercury only stops the oxidation of zinc. Okay? If I write here 2HCl, it will give me zinc fluoride, 2 nascent hydrogen, and mercury will separate because mercury is reduction potential is positive, so it can never displace hydrogen from acid. Okay, now I'll write it here now. Suppose I have taken here CH3COH. See, how many hydrogen I require? Because I have to convert into corresponding hydrocarbon. Balancing chemical equation is not at all difficult. See here. This carbon had one hydrogen. Now it is having 3 hydrogen. So 3 minus 1 is 2. But this oxygen has to go out. So this oxygen will go out in the form of what? Water. So total number of hydrogen required is what? 2 plus 2, 4. So I'll write now here 4 atomic hydrogen or nascent hydrogen. Over there, what I'll write? Zinc, Hg, HCl. And here I'm going to write 6. Let depth. So if I do with benzaldehyde, what I'll get? With benzaldehyde, I'll get toluene. If I go for benzaldehyde, so similarly, right here, 4 hydrogen. zinc, mercury, HCl, heat, I'll get here toluene and okay. Every time I'm not going to write this one, huh? Because so suppose I have taken here, what is this? This is cyclohexanone. They will give you intentionally this one. See, every carbon is having CH2. So I'll write now here 4H. Then zinc, Hg, HCl. So what we are going to get 3 here because of that I have given. This is CH2, CH2. This also will be converted to CH2. So this is the one. So you get cyclohexane plus water. You get here now cyclohexane. Plus. Tell me after finishing.
Yes, sir.
Finish now? Very good. Now we'll go for Wolff-Krishna reduction. Wolff-Krishna reduction. So please write down. Right. In this method, aldehydes and ketones, Wolff-Krishna method, huh? So the Wolff-Krishna reduction, that after. In this method, aldehydes and ketones are heated with excess of hydrogen, in presence of strong bases. Spelling of hydrogen is HYDRAZIN. Excess of hydrogen in presence of strong bases like potassium hydroxide, KOH, or potassium tertiary butoxide, BUTOXIDE. Okay, so you should know how potassium tertiary butoxide looks like. Okay, see, this is the structure of potassium tertiary butoxide. Draw potassium tertiary butoxide. in, okay, first you write the structure. Right. In ethylene glycol, at high temperature. Okay. So now I'm going to write the reaction. Okay. So first I'll show you the general reaction. Then you will do it by yourself. See, this is a carbonyl group. It may be aldehyde or ketone. So I am now reacting it with hydrogen. Only yesterday you have seen that carbonyl group immediately gives you hydrogen derivative. So it is hydrogen and you will get here now hydrazone. Then we treat it with potassium hydroxide. In exam, you need not write potassium tertiary hydroxide. Okay? Or potassium tertiary butoxide. Now, what solvent we are going to use? Ethylene glycol. Why? Because it requires lot of temperature, very high temperature to require. Okay? So, what will happen now? These two hydrogen here from this nitrogen will shift to carbon. So what is we are going to get? See, it just come to carbon. And this will go out in the form of nitrogen gas. Okay? This will go out in the form of nitrogen gas. Now, please do this reaction with acetaldehyde and do this reaction with cyclohexanone. Please do. Or I have to do. I have to do only. You are so lazy. Huh? So you write here. So I'll write now here. Here I'll write only KOH. And here I'll write, you don't have to write this. Okay, I'll write now. Glycol. You know, write the formula. Oh, I have to write here heat. You write here heat. So what you will have now? Here, you will get here ethane and nitrogen. Okay. So this one I'll write it here, no space to write here. So this is cyclohexanone. And here I'm going to write this one as this. Okay. And what I'll write now here, you know it will give me cyclohexane. Okay. Remove all these things. Things which you cannot remember, forget. Then you write here heat. দরকার আছে আমরা জলটা তো ময়লা Finish. Right fast.
Yes, sir.
Okay. Now, both these reactions are important for your exam. Both these reactions. All right. Now, I'll do one more reaction which is not in your book. That is, write down. Aldehydes and ketones can be reduced to corresponding hydrocarbons on reduction with hydrogen iodide HI in presence of red phosphorus at 423 Kelvin. Okay, so this I am only going to write a general reaction. So right now here, see, I require 2 here and 2 here. So I'll write now here 4HI. And here I'll write red phosphorus 423 Kelvin. So I'll write it like this. You should know all these things for your entrance exam. And this one will go as iodine molecule. Okay, finish.
Yes, sir.
Okay, now we'll go for oxidation. Okay, below that you write oxidation of aldehydes. Oxidation of aldehydes. Then write aldehydes are very sensitive to oxidation. And these can be oxidized by even mild oxidizing agents such as Tollens reagent, okay, within bracket you write ammonickel, silver, nitrate. Then failing solution that I'll explain later on. Failing solution, these two are given in your textbook. Then write Benedict solution, Then write shifts reagent, then write bromine, water, etc. 2 CO2 corresponding carboxylic acid containing same number of carbon atoms, containing same number of carbon atoms. You will underline this 4 words, same number of, sorry, not 4. Say underline this same number of carbon atoms. Okay. So now, right below, oxidation with tolerance reagent. Oxidation with tolerance reagent. Right. The tolerance reagent is ammonical silver nitrate solution. Tolerance reagent is ammonical silver nitrate solution. So I'll show you how tolerance reagent is being prepared. So I'll write here now silver nitrate. To that I give here ammonium hydroxide. It will undergo double displacement reaction. Silver hydroxide. Silver hydroxide is a precipitate. So immediately silver hydroxide will form a complex with ammonia. Okay, I'll write here now. NH4OH. So what it will form? It will form this. This is tolerance reagent. What is its name? That we will learn when we go to production chemistry. But you should know. It's called diamine. Double M is there. Silver. One is the oxidation state, and this is the anion. It's called diamine silver 1 hydroxide. Okay, this is called tolerance reagent. So finish.
Yes, sir.
Yes, sir.
Okay. Now we will do one general reduction. After that, you will do it. See, I have taken an aldehyde. and to that I have added tolerance. This tolerance reaction, so you will suppose everything goes fine, then you will be doing this test in the laboratory also. Okay? So I have taken tolerance reagent. See what is going to happen now. Look here. How many hydroxide is there? 2. So I'll write like this. Don't write. You don't write. 2H minus. So 2H minus can be written as H2O plus O. This oxygen will go here. Okay? This oxygen will go in between this carbon and hydrogen, it will oxidize it. Alright? So I'm going to write it in this way. R C O H. Don't write. 4 ammonia plus H2O. See here. How many ammonia there? 4. So I've written here 4. How many OH we had? 2. So I already shown you H2O from one oxygen goes here. So this oxygen has come here. Equation is balanced. Look here. This is an acid and this is a base. Acid and base, if they remain in the same solution, will it not form salt? Yes. So in that case, I'll write here in your book also they have written. It will be ammonium salt and here this will be CNO. So this is the balanced equation. Okay. So please do this one with acetaldehyde and one with benzaldehyde. Huh? Do it. Huh? At the same equation. Here R is CH3 and here R is this aromatic. This is acetaldehyde and this is benzaldehyde. Plus 1 minute for each equation. filter जल्दी जलाओ. Omid Das is there or busy for exam? Omid Das, hello, missing. Acha, now, Mr. Slong, hello. Damian Slong, Damian is there. Aishman, hello, Aishman. No reply. Then Ankita, is not there. And the new lady who has joined yesterday, I think, what is her name? I forgot what? Mimi or something like that.
Kimi.
Huh?
Kimi.
Oh, Kimi. Achha. All right. So finished?
Yes, sir.
Okay. So this is the tolerance reagent. Okay. Now we'll go for Fehling solution. Right. Second, Fehling solution. Fehling. Right. Fehling solution is made of filling solution is made of equal volume of two solutions. Equal volume of two solutions. Okay, put a colon and write fillings A will be capital. Fillings A and fillings B. Okay, then write next paragraph. Right. Fillings A is a dilute solution of copper sulfate. Is a dilute solution of copper sulfate. And fillings B is an alkaline solution of Rochillis salt. Rochillis salt. Don't write chili. Rochillis salt. Within bracket, you'll write sodium, potassium, tartrate. Okay. How does it look like? See here. This is sodium potassium tartrate. Mind it. This is being used in our true baking powder. Baking powder, actual baking powder is a mixture of sodium potassium tartrate and sodium bicarbonate. But it is costly. So we go and buy from the grocery shop Khaneka soda, means sodium bicarbonate. But actual baking powder is a mixture of sodium potassium tartrate and sodium bicarbonate. Okay. So this is important for your multiple choice question in entrance exam. Okay, Ladder. Very good. Can I wrap it?
Yes, sir.
Okay, now see here. When I mix both of them, see what is there? Copper sulfate is there in fillings A. Fillings B is what? What do you say? Alkaline solution. Generally, we add here sodium hydroxide or potassium hydroxide. See what is going to happen? It gives us copper hydroxide and sodium sulfate. Okay. If it is so, then what for we have used this one? No problem. This is being used to stabilize copper hydroxide. See, in copper hydroxide, how many OH groups are there? 2. So, in that case, what happens now? See, in this case, here oxidation state of copper is +2. So what happens now? Out of this 2 oxygen, 1 oxygen remains with, 4 oxygens are there. No, 2. So in that case, out of the 4 OH, try to understand, don't Magab chemistry. So I can write here 2H2O, one oxygen will go to copper, see, because of that, and one oxygen will go to the aldehyde. So this is the oxidation takes place. Huh? So I'll write it. So this is, don't write this one. Otherwise, so after a few days you'll forget and you'll think what rubbish sir has written. Huh? Okay. So see, I'm extremely scared of you. Huh? If you put me in deep forest in Africa and if I meet gorilla and tiger also, I'm not scared. But you people are dangerous. Okay, I'll write now this. R C H C. And here I'll write 2 cupric hydroxide. See what is going to happen. Just now I told you that one of the oxygen will come here. So what you will get now here? You will get it this. Then one oxygen has come to copper. You get this. Then what is left out? 4 hydrogen and 2 oxygen, 2 H2O. Now dear, is it not alkaline mixture? Alkaline mixture is there. So I'll write now here NOH. See, acid and a base. So क्या होगा? It will form salt. It is going to form salt and water. So one more molecule of water will come. So 2 plus 1, 3. So this is the equation for saline solution. So this cupric hydroxide is red in color. You will get a red precipitate. So after that, you will write only one equation. This. I'll tell you why did I tell you. You write one equation. It's not that I've suddenly become very kind in heart. Not like that. Achha. So Miss Aditi is there. Aditi Kashyap. Aditi. And Miss, the soft-spoken lady is also there. Huh? Hello? I think all army school students are missing because of physics exam. I think. Then Miss Drishti is there. Miss Drishti?
Yes.
Acha. So do it. Finish. This one? Exactly you have to write here. Only instead of R you have to put CH3. Finish?
Yes, sir.
Okay. Now write here. Note. Right. Note. Right. Right. Aromatic aldehydes do not react with failing solution. Aromatic aldehydes do not react with failing solution. All right. So this is important for you. Why? You know why it is important? You know, in exam the question will be asked that how can you distinguish acetaldehyde from benzaldehyde? How can you distinguish? So don't write. The spellings are different. Hmm. People can write anything. In this year, in both exam, one question came: what is auto reduction? Student has written that reduction which is carried out in auto rickshaw. Okay. So what we will write now? We will write that acetaldehyde produces a red precipitate of cuprous oxide on reaction with saline solution, while benzaldehyde no. That's only for you don't have to write any equation. Only for that you'll get 1 out of 1. Now we'll discuss 3 more only for your entrance. Finish?
Yes, sir.
Okay. Then right. Now whatever the thing that I'm going to do, you can write there for entrance. Right. Benedict solution. Benedict solution. Right. It is an alkaline solution of copper sulfate. Benedict solution. It is an alkaline solution of copper sulfate containing citric acid. It is the same thing of filling solution. But here, filling solution, we make it by mixing 2 solutions. Here, but here, only 1 bottle is there. Right. It oxidizes aldehyde to corresponding carboxylic acid. It oxidizes aldehydes to corresponding carboxylic acid, and forms a red precipitate of cuprous oxide. Right. Finish?
Sir.
Finish?
Yes, sir.
Right. This solution is used in hospitals. This solution is used in hospitals and pathological laboratories. What is pathological laboratories? Where we do all the tests. And pathological laboratories to detect glucose in urine for diabetic patient. For diabetic patient. Okay. Then right. Next. Right. Done.
Yes, sir.
Then right next. Schiff's reagent. Schiff's. SPHIFF apostrophe. Schiff's reagent. Right. It is a solution of, it is a colorless solution of freshly reduced. It is a colorless solution of freshly reduced rosaline hydrochloride. Okay. Within bracket, you'll write magenta. I think, see, all of you have seen this one. I'll tell you, let me finish the statement. Right. On oxidation, sorry, after oxidation of aldehyde, after oxidation of aldehyde, it gains, it gains, it gains its pink color. Okay, now I'll tell you what is magenta. See, this color is being used during playing Holi. You will see, people sprinkle this pink solution on others. This is nothing but toluene hydrochloride. But what it is being done is once you reduce it, it becomes colorless. So after oxidation of aldehydes, again it gets back the own color. So in the laboratory, you will get, if you put this colorless solution, and after oxidation, you will find the solution has become pink. So these are all the two extra. But now one more is a bromide water oxidation. Okay, bromine water oxidation is not being given. Anyway, I'll do it. We know halogen are strong electronegative elements, and always electronegative elements are good oxidizing agents. So we are not using chlorine and fluorine. Why? Because they are extremely toxic, and bromine is liquid, so it is easy for us to make. See here. If you add bromine in water, what happens? After some time, you will get bromine hydrobromic acid. So this is the oxygen which oxidizes the aldehyde. Okay, aldehyde, I told you, is very sensitive to oxidation. So we do it. In laboratory, if you have taken an aldehyde, and through that if you add bromine in water, after some time you will find brown color of bromine vanishes. So that it means is this one. So what is going to happen now here? Suppose you have taken here this, and to that I have added bromine water. Okay, see there, this oxygen will come here, and in that case you will get here carboxylic acid. There is no base to form salt, and you will get here 2H here. I wonder why such simple equation is not being included in your book. I'll take 10 more minutes to finish the oxidation of ketones. So I have done detailed oxidation of aldehyde only for your entrance exam. Finish?
Yes, sir.
Okay, then write oxidation of ketones. Right. Unlike aldehyde, ketones do not undergo oxidation under ordinary conditions. Right. However, when strong oxidizing agents such as sodium chromate, sodium dichromate, potassium dichromate, KMNO4, concentrated nitric acid, on boiling condition get oxidized to a mixture of carboxylic acid each containing lesser number of carbon atoms compared to original ketones. Okay, so I'll do it now. See here. I've taken here acetone. Acetone contains 3 carbon atoms, and this is a symmetrical ketone. Okay, this is acetone, and this is a symmetrical ketone. Both sides is containing same number of 1, 1. Symmetry. Well, and I'm oxidizing it. What is the condition? Condition is say is K2Cr2O7 or KMnO4 in what? Concentrated H2SO4 or concentrated HNO3 under boiling condition. What is going to happen? You don't yes. This will break and each part will get oxidized. So this will get oxidized here. So it will be CH3. Okay, I'll write here first like this. Plus I'll write here this. This will be oxidized to what? Carboxylic acid. This will be oxidized to what? Carboxylic acid. Let me write here OH. Then what is left out? Hydrogen. You will get here. So you get a mixture of acetic acid and formic acid. See, carboxylic acid you cannot oxidize further. But look at this. Look at this molecule. If I look from this side, what is the functional group? COH. And if I look from this side, what is the functional group? Look. So it has an aldehyde unit. This is very important to remember. If I look from this side, from here I see carboxylic acid. If I look from this side, it has an aldehyde. So this gets further oxidized. What will happen now? Again it will get oxidized. So what will happen now? When you oxidize this one oxygen will enter. It was organic acid. And after oxidation, what has happened? Look, very interesting. The organic acid is being converted into inorganic acid. Why? Because this is carbonic acid. And carbonic acid is not stable. You have seen it. In your soft drink, forcefully you put water, sorry, carbon dioxide. So what do you get? You get the same one, carbonic acid. When you open the bottle, what happens? This decomposes to give you carbon dioxide. Carbon dioxide comes out from there. So, what will happen now? This is very, very important for entrance exam. Most of the people, they make mistake because they learn only the theory. So, they will tick here, both of them. No, it will get oxidized. So, what you are going to get, acetic acid will not be oxidized. And this will be oxidized to water and carbon dioxide. Write it. Who knows? It may come in next entrance exam. And if it comes, then you remember me. That old fellow has told us. This is for symmetrical ketone. Okay, I'll finish within 5 minutes. Now see here. I have taken an unsymmetrical ketone. CH2, CH2, CH3. Now the question is symmetrical ketone, if I break it from any side, I'll get the same product. In case of unsymmetrical ketone, the question is where it is going to break. Should it break it here? If we break it here, 1, 2, 3, 4, we'll get butanoic acid, water and carbon dioxide. And if it breaks it here, then I'll get acetic acid, 1, 2, 3, I'll get propionic acid. Please remember, In case of unsymmetrical ketone, the smaller alkyl group will always remain with the carbonyl group, so it will break here. So before writing this example, write one statement. Right. In case of unsymmetrical ketones, comma, the smaller alkyl group remains with
Pardon, sir.
in case of unsymmetrical ketones, comma, don't write by spelling, huh? The smaller alkyl group remains with smaller alkyl groups remains with, see this one, carbonyl carbon. This is going to stay with this. Remains with carbonyl carbon. Alright. So this rule has a name. Alright. This rule is called, very nice name, huh? You can make a sound and also you can remember. Popov, like this. Popov's rule. Within bracket you write. It's called Popov's rule. Okay? So what should I write now here? I'll write here now. And here you can write, say you written here KMNO4, H2SO4, or concentrated HNO3, 3. So I'm going to break it here. So this will be oxidized to what? This. And this will only be oxidized now. It will be CH3, CH2, COH. So that's for today. I'll take 2 more days to finish. This is very big. Then I have to start carboxylic acid. I'm going very detailed only for your entrance exam. Rumah Sanchez. I'm going to go Muslim. No, Thakur is good. Finished?
Yes, sir.
Yes, sir.
Then bye. Bye. Good day.
Thank you, sir.
Bye, sir.
Thank you,
Thank
sir.
you, sir.
Uh.
Thank you,